Solving quadratic equations by factoring, Part 1. In this lesson, Joe will solve quadratic equations by factoring. Joe's math teacher taught him that quadratic equations that have one or two solutions may be separated into two linear expressions which can then be used to find the solutions of a quadratic equation. In this lesson, we'll learn how to do it. Before we start, we'll mention a couple things. Solving by factoring is a very fast and easy way to solve quadratic equations, but solving by factoring will not work if an equation has no real solutions or has no rational solutions. In this video lesson, all equations will be solvable by factoring, but outside of the examples in this lesson, if you cannot solve by factoring, try graphing the quadratic formula or completing the square. The factoring techniques we'll use in this lesson are: first, factoring out a greatest common factor; second, factoring a quadratic trinomial; and third, using a difference squares method. Warning, warning, warning. Finding factors of quadratic expressions is only an intermediate step to finding solutions to quadratic equations. If you stopped after finding the factors, you may be wrong. From finding the factors, the solutions may be counterintuitive, which means that they may not be what you'd expect at first glance. Be careful. Be vigilant. Joe remembers from Algebra 1 class finding the product of two binomials by using FOIL, but before that he learned the box method, was quite logical, and was easy, at least when first starting. We'll start with these two binomial factors, quantity x plus 3 and quantity x minus 5. When I say the word quantity, I mean that the two terms I mentioned after the word quantity will be inside parentheses. Each term from one binomial goes on the top of each column of the box, and each term from the other binomial goes at the left side of each row of the box. Each term in each binomial is thus multiplied by each term in the other binomial. That's x times x equals x squared, negative 5 times x equals negative 5x, 3 times x equals 3x, and negative 5 times 3 equals negative 15. The two x terms, the 3x and negative 5x, are combined to equal negative or minus 2x. The product of these two linear binomial factors is the quadratic trinomial x squared minus 2x minus 15. Factoring is working backwards from finding the product by multiplying. In other words, we start with the quadratic trinomial, like this one, n squared plus 2n minus 3, or maybe even a quadratic binomial, and find the factors of that product or expression. The equation has to be equal to 0 on one side to solve by factoring. If one side of the equation does not equal 0, we will need to make that one side equal to 0. And for this first problem, we'll start with the trinomial n squared plus 2n minus 3, which is already set equal to 0. First, look for a factor common to each term. There is no common factor between these three terms. Our first step is to place the n squared term in the upper left cell of the box and the numeric constant term in the lower right hand corner of the box. Working backwards, we place an n at the top of the first column and at the left side of the first row, because n and n are the factors of n squared. Now comes the challenging part. We're looking for the two numbers that multiply together, which equal negative 3, but when added together equal the coefficient of n, which is 2. A systematic approach to finding the factors is to create two columns. The first column on the left for the factors of that number in the lower right hand corner, in this case negative 3, and another column on the right for a list of sums of these factors. The only two combinations of integers to get negative 3 are negative 1 times 3 or negative 3 times 1. We list the factors in the factors column. The next step is to get the sums of the two factors and place them in the column under sums. We have negative 1 plus 3 and negative 3 plus 1. And here the factors are added together to be 2 and negative 2. This is the combination that has the sum of 2. We match the 2 in the sums column with the 2 that is in the coefficient of the linear term. This means that the factors of negative 3 are negative 1 and 3, which we place on the side and top of the box. And part of the check is to multiply them out. N times 3 is 3n, and negative 1 times n is negative n, which added together equal 2n. And we see that the factors are quantity n plus 3 times the quantity n minus 1. We write them out below the original trinomial, still set equal to 0. Based on what we see here, our solutions are n equals 3 and n equals negative 1. Danger, danger, danger. That is not the answer. Our solutions are not n equals 3 and n equals negative 1. We need to find the values of n that make the equation true. So we split the binomials into two separate equations. This is what we call using the zero factor property of algebra. The zero factor property is essentially that anything multiplied by 0 equals 0. So we set each of the two factors equal to 0. So we have n plus 3 equals 0 and n minus 1 equals 0. We solve the equations on the left, and n equals negative 3 for the equation on the left, and n equals 1 for the equation on the right. And to check, we can put each calculated solution into the original trinomial to assure that our solutions are correct. The confirmed solutions are n equals negative 3 and n equals 1. Joe will solve this equation by factoring 3a squared equals 18a. The first thing we do is make one side of the equation equal to 0, and we do that by taking the 18a term on the right side and moving it to the left side of the equation. We have 3a squared minus 18a equals 0. Is there a common factor between these two terms? Yes, 3a. So factoring out the 3a, we get 3a times quantity a minus 6 equals 0. Now using the zero factor property, we set each of the factors equal to 0. So we have 3a equals 0 and a minus 6 equals 0. And solving both equations for a, we get a equals 0 and a equals 6. And in set notation, we say that a equals 0 and a equals 6, which we box in as our correct answers. Let's look at this equation. X squared minus 16 equals 0. If you see that you can take the square root of each term in a difference, we can factor using the difference of squares method. This equation applies for the difference of squares method because we can take the square root of x squared and also a square root of 16. So here are the two sets of parentheses set up. Here the square root of x squared goes here, which is x and x, and then it's plus on one binomial and minus on the other because a plus times a minus equals a negative. And then we take the square root of 16 as the final term in each binomial, and that is 4. Next we use the zero factor property of algebra and set each of the factors equal to 0. Solving for x, we have x equals negative 4 and x equals 4. So our solutions are x equals negative 4 and x equals 4, which we box in as correct. Since there is no linear term in this original equation, we could also have solved this equation using the square root method. Let's look at this equation. X squared minus 4x equals 12. Stop the video and solve this equation by factoring, then restart it to see if your solutions are right. Hint: set one side of the equation equal to 0 first. Our first step is to get one side of the equation equal to 0, and that is most easily done by moving the 12 on the right side of the equation to the left side of the equation. This is subtracting 12 effectively from both sides of the equation. Now we have x squared minus 4x minus 12 equals 0. Is there a common factor between the three terms? No. The x squared term goes in the upper left cell, and the constant term, negative 12, in the lower right cell. We place the factors of x squared in their proper places on the top and to the side. We set the columns for factors and sums. We list all the factors of negative 12, which are quite a few. Next, we add the two factors together from the left column to get in the sums column on the right. We look up at the x term in the quadratic equation. Its coefficient is negative 4. Is there a match in the sums column? Yes, right here. Both the coefficient of x and the sums of the factors are negative 4, those factors being negative 6 times 2. This means that these two numbers, negative 6 and 2, are the factors that should work. We insert these factors of negative 12 to the top and to the side of the box here. We have the negative 6 on the left side and the 2 on the top of the box. And multiplying out, we get 2x in the upper right cell and negative 6x in the lower left cell. We see that the terms in these corners of the box sum to negative 4x, proving that the factors are quantity x plus 2 and quantity x minus 6. We rewrite the quadratic equation in factored form. Quantity x plus 2 times quantity x minus 6 equals 0. Do not stop here. The solutions are not x equals 2 and x equals negative 6. Using the zero factor property, we separate them into two equations. X plus 2 equals 0 and x minus 6 equals 0. Solving both equations for x equals negative 2 and x equals 6. we rewrite the answer in set notation here. We can substitute negative 2 in for x, and it works as well as substituting 6 for x, 2 solutions. Let's look at another problem, a multiple choice problem about finding solutions by factoring. Which are the solutions to the quadratic equation quantity x plus 3 times quantity x minus 4 equals 0? When you see a problem like this, the test writer is setting you up. You see the 3 here matching the 3 in the answer choice, and the negative 4 here at the top matching the negative 4 in the answer choice. The test writer is wanting you to bite on this one, but it's not the right answer. To solve, you need to write 2 separate equations, one for each binomial. One equation is x plus 3 equals 0, and the other equation is x minus 4 equals 0. To solve the left equation, we subtract 3 from both sides, so x equals negative 3, and for the right equation, we add 4 to solve for x, so x equals 4. Our answer is C. Don't be tricked. Factoring these quadratic expressions will get a lot easier with some practice. Let's take a last look at solving a quadratic equation by factoring. We have the equation x squared plus 7x equals 18. Stop the video lesson and solve by factoring, then restart to see how you did. As we have done in the other examples, we solve one side of the equation for 0. We'll do this by moving the 18 on the right side over to the left side of the equation. We get x squared plus 7x minus 18 equals 0. Now instead of a box, we'll set up parentheses to factor this quadratic trinomial, which is less work than setting up a box to factor. The first thing we'll do is put the factors in for x squared, which are x and x. Now we need to find the factors of negative 18, and because 18 is a negative number, one factor must be positive and one factor must be negative. The thing we pay attention to next is this number 7, which is the coefficient of our linear term 7x. Now we ask ourselves the question, what 2 factors of negative 18, when added together, equal 7? The answer to this question is the key to solving this equation. The numbers we'll look at are 9 and 2 because the difference between these two numbers is 7, and also when multiplied together, these two numbers equal 18. Since we need positive 7, our 2 factors of negative 18 will have to be 9 and negative 2, because 9 and negative 2 when added together equal 7. We need to place the 9 and negative 2 in their places inside parentheses. As a check, we multiply all terms by each other in the 2 binomials. We get x squared plus 9x minus 2x minus 18 equals 0, which simplifies to x squared plus 7x minus 18 equals 0. So these factors are good. Check. So now we'll go about solving the equation by using the zero factor property of algebra and set each of the 2 factors equal to 0. Solving each equation for x, we have x equals negative 9 and x equals 2. And we box in our answers as correct. And here are the different methods of solving quadratic equations that we'll be covering in this series. In addition to the method of factoring just seen, we have the square root method, solving by graphing, using the quadratic formula and completing the square. You may click on any of these to go to that particular lesson. In addition, there's a solving quadratic equations flowchart that filters you through the different techniques of solving these quadratic equations. This has been Solving Quadratic Equations by Factoring, Part 1. Thanks for viewing.